So let us discuss this very important concept, that is partial derivatives. Partial derivative, that means if we have a function of two or more variables, we find the derivative of function with respect to one variable by treating remaining variables constant. So we call it as a partial derivative. Okay, so let us see the mathematical definition first. After that we will discuss it in details. See, let what I am considering S be a subset of Rn, which is obviously non-empty. So that means what we have, so this is S, which is a subset of R. Okay, let I am taking one point A is equal to A1, A2 and so on n, which is element of S. So I have taken one point A here. See, A is a element of S and which is subset of Rn. So that's why obviously A has n number of components. Let F defines from S to R be a scalar field. Be a scalar field. Okay, I will show here in diagram. So F is a function from A to R set of real numbers. Okay, 1, 2, 3, 4, all these numbers. Then partial derivative of f with respect to xi. See, I am calling it as with respect to xi means what? Here n number of components are there, x1, x2, x3 and so on xn. So it has total n independent variables. So we can find derivative of f with respect to x1, we can find derivative of f with respect to x2, and in the same way we can find derivative of f with respect to xn. So I am finding a general derivative with respect to xi. With respect to xi is, so it is defined in this way. Okay, we write in this way, del by f by del by xi. You can call it as del by f by del by xi or dou f by dou xi. Both of them are valid. At point A, see, it is defined in this way. Limit h tends to 0 f of a1, a2 and so on ai plus h and so on an. So what I am doing, I am simply adding h only in ith component, since we are taking derivative with respect to xi. So when we take derivative with respect to x1, we will add h only in first component. When we take derivative with respect to x2, I will add h only in second component. So similarly for xi, I should add in ith component minus f of a1, a2 and so on n. Here I do not add anything, simply I take f of a1, a2 and so on n divided by h. So in this way, by solving this limit, we find derivative of f with respect to xi. So provided limit exists, So that means if limit exists, then only we can find partial derivative. Otherwise, we can declare partial derivative does not exist. When f, any function, depends on two or more variables. Okay, I will simply give idea to you. Suppose we have function f of x, y, z, which is x square plus y square plus e raised to z. This is one simple example of a scalar field. So you can find partial derivative with respect to x. We denote it as in this way, del by f by del by x. You can find partial derivative of f with respect to y. We can denote it by del by f by del by y, and we can find derivative of f with respect to z. That will be del by f by del by z. So this is the main definition of partial derivative. Let me remove this one. After that, it is better to note down this definition. You can make a screenshot of it, and after that we will go further. Let us discuss one special case of it, so it will help us to understand the concept. Okay, so what I am doing, I am considering let f be a function from R3 to R. Let I am taking one point A is equal to A1, A2, A3. Obviously, we need to take element from domain. Okay, so now I am going to find, see, R3, that means 3 components are there. So we can find derivative with respect to x, with respect to y and with respect to z. So let us discuss their definitions. Then del by f by del by x at point A. A means you know that A1, A2, A3. So this is equal to limit h tends to 0 f of, see with respect to x, that means with respect to first component getting, so it will be simply a1 plus h a2 a3 minus f of a1 a2 a3 divided by h. Okay, dabba f by dabba y at point A. Can you guess the definition? Definition will be like this: limit h tends to 0 f of a1. See with respect to y, that means with respect to second component. So I need to add h only in second component. Okay. So this is a2 plus h and a3 minus f of a1, a2, a3. See the second term is unchanged getting, so it is same, just we have to make changes in first term. Okay, so the last possible derivative is dabba f by dabba z. I am sure that you can easily guess its definition. So its definition will be limit h tends to 0. Tell me, this is f of a1 a2 and I need to add h in third component only. Next term will be same, f of a1 a2 a3 divided by h. So in this way, by using this definition, we can find their partial derivatives. Let us discuss one example on it. Okay, but you can make a screenshot of it and after that we will go further. Let us discuss this example. So we have a function here of two variables x and y. So two variables are there, so only two possible partial derivatives are there. So we can find dabba f by dabba x and we can find dabba f by dabba y. Okay, we have to find their values at this point 0, 0. So let us apply the definition. I will simply write by definition. Let us calculate dabba f by dabba x first at point 0, 0. So limit, obviously by definition, limit h tends to 0. At 0, 0 we have to find, and with respect to x, with respect to first component. So I suppose to write f of 0 plus h 0 minus f of 0, 0 divided by h. See at point 0, 0 getting now, so that's why I am writing here 0, 0, and with respect to x, that with respect to first component, so that's why I am adding h in first component only. So this is equal to limit h tends to 0 f of 0 plus h minus 0 minus f of 0, 0 divided by h. Limit h tends to 0. What is the definition of f? You can easily see here, this is our f. Okay, our x is h and our y is 0. If I put x is equal to h, y is equal to 0, what will happen? See, we will have 3h square, correct? Y is 0, so 0 into anything 0 we will have, plus y 0, so 0, plus 6x, x is h, so 6h we will have, minus f of 0, 0. If I put x is equal to 0, y is equal to 0, we will have all terms are 0. So 0 divided by h. So this is equal to limit h tends to 0, 3h square plus 6h divided by h. See, I will divide separately. Then what will happen? So this is equal to limit h tends to 0. If you divide separately, here 1h will get cancelled. We will have 3h plus here h will get cancelled and we will have 6. Now we have to apply the limit. That means simply I have to put h is equal to 0. So what will happen? If I put h is equal to 0, 3 into 0, 0. And 6 is constant, so we will have only 6. So this is a dabba f by dabba x. This is value of dabba f by dabba x at point 0, 0. Similarly, we will calculate dabba f by dabba y at point 0, 0. Okay. See, now I will write now dabba f by dabba y at point 0, 0. So this is equal to, there is no much space. I will write here limit h tends to 0 f of. See, now we are finding derivative with respect to y, that means with respect to second component. So I will add h only in second component. So this is 0, 0 plus h minus f of 0, 0 divided by h. So limit h tends to 0 f of 0, 0 plus h minus f of 0 0 divided by h. Okay, so this is equal to, so let us find their values and we will put those values there. Limit h tends to 0, f of 0 comma h, see this is our f, definition of f, our x is equal to 0 we have and value of y h we have. So let us put their values here and find their actual value of f of 0 comma h. I am putting x is equal to 0, so this is 0 plus x is 0, so 0 into anything 0 plus y is equal to h we have, so we will have 8h and x is again 0, so therefore we will have 0 minus f of 0 0 is obviously 0, since if I put x and y both of them are 0, here we will have 0, so 0 divided by h. So what we are getting finally, limit h tends to 0, 8h divided by h. So h will get cancelled, limit h tends to 0 and we will have 8. If we apply the limit, that means we have to simply put h is equal to 0. But there is no any h since 8 is a constant. So we will have the same limit which is 8. So in this way we calculated partial derivative of f with respect to y also. So very good example we have discussed here. You can make a screenshot of it and after that we will stop. Thank you. Bye bye.